Hello. Today we are come with the project based on data science. In this project, we will see that the iris. After moving towards the video, we will see how what is actually the iris and how can we apply ML algorithms. Afterwards, we will see how the data science are going to implement in it. So first of all, we have to know what steps we are going to focus on this project. So number one step is we are going to load the data. Let's suppose any kind of data we have taken from. Afterwards, we are going to load the data. After loading, we are going to visualize the data, that how our data is actually look like. After that, we are going to model the model training. In this, we will give testing and modeling by using our dataset. Afterwards, we are going to evaluate the accuracy of our model. That say we have we are checking that whether our model is accurate or inaccurate. So we are going to check accuracy. Then we are going to evaluate the visualize the model, that the model we have used, like decision tree or any kind of model which we are going to use, an analytical model which we are actually going to use. We will see that how our model is actually visualized. Is it okay, or we should have to use another model for better accuracy? Afterwards, we are going to test the model. Let's suppose we are going to give any raw data and check whether our model is actually predicting the required field or not. So all these kind of things are going data science. It is a certain not a big but intermediate data science project which we are going to use in this cell. So in this video, you are going to learn a lot of things. So first of all, we are going to know that what is our basically iris. So in order to understand this, we are going to see this here like this. So this is our iris. Iris is a kind of flower. So in iris, there is actually what data we have given. In iris, we are going to receive the data of like sepal length, sepal width, petal length, and petal width. These are the raw data which we are going to take from. Either you are going to visualize it by using downloading the data from Kaggle or any other method which you want actually. So these are the four parameters which we are going to use in this. So this is actually, in order to understand, we are going to visualize it here like this. This is our like iris flower. In the iris flower, this is petal length. Vertical length is petal length. This is petal width. This is sepal width and this is sepal length. So these are the lengths which we are given here. So on the basis of length or width or any kind of thing, we are going to see that iris has basically three species. So we are going to differentiate, classify the models, classify the flowers by using our model. So in order to do this, we should know that what is petal length, petal width, sepal and sepal width. I hope you understand this, that this is sepal length and this is sepal width, while this is petal length and this is petal width. Afterwards, we will see that how actually our species look like. Species of iris look like. So this is iris setosa. This is one of the species of iris. This is the another versicolor, and this is virginica. So basically, you are going to give three species in which your model is going to verify that the testing condition which you have given either satisfy this model, or this model. So in this method, we are going to use data science and implement here. I hope you understand the whole psychology of this project. Let's come on to the project and we are going to use it here like this. So let's start from the basic. First of all, we have to load the data. So in order to load the data, we have to use import library of Panda. So import pandas as pd. Afterwards, we are going to see that, let's suppose you are going to read the file. So in while using the file, you have to give any kind of variable. So I'm just using df. Df means data frame. So data frame is equals to Now we are going to read our Excel or CSV file which we have done in the previous kind videos. So we are just applying the same method here, pd dot read csv CSV, and after that you are going to copy the path of your file which you have downloaded. So I have downloaded it from Kaggle. You can use Kaggle also in order to take your data set. So I have just downloaded, so I don't need to download again. You just have to go to Kaggle and download the iris dataset. It is just simple like that, nothing else. So in the download portion, as you see that iris, this is my download file. I just copy as path. Now after copying it, uh, I will come to my file again and this copy and paste it. While you are reading the file, you just put R here like this. Now if you want to check any five uh, rows actually, so you just use head. If you want to read all the file, just you will write print df, but just don't want to read the whole file. I just want the part, any five rows to be uh, print. So I just will you what kind of word which we use is actually head. So head is the command which print only five. Head means head of the file. It means that you have any kind of data, it just print five numbers of rows in order to see completely here. So we are just using head here to print five rows. If you want to print the whole file, you just use printf. I am not going to use it here because I just don't want my whole file to be read here. I just want to see my five rows. So I will just implement this here like this. Now we will wait and see that what happened with the result. So as you see that our sepal length, sepal width, petal length, and petal width, we have been received our data set in this form. So we have read the file. Now after reading the file, we are going to visualize the data, that how our actually file looks like. So in order to visualize your data step by step, you are going to use uh, I am just going to see the histogram here. So in order to see histogram, you will just use this command like import matplot library dot pyplot splt. You can either copy it, you just don't have to remind it, it's a part of code. So you just either copy it once and you will use it again and again. So plot dot figure df. So what, which one is you are going to visualize here, so it depends upon. So I am just going to see my sepal length, so I will just df control c control v. Comma bends. So this is basically the prefix fixed syntax which you can use. You just don't have to remember this. You just either copy from any kind of AI agent, by using any kind of AI agent. You just don't use to remember this kind of codes. It is basically the matplot which you can easily get by using Wikipedia, Google. So comma edge color equals black. Now you are going to label the x label and x axis and y axis. So you will use plot dot x label. On the x label you are using actually sepal length. So you will just copy it like this. Control C, Control V, and this is actually in centimeters. So you will put centimeter in the bracket. We are going to in the detail process like this. Afterwards, close the bracket. Now you are going to use y label also. So just either copy this, Control C, paste, make the y label, and this is actually count. On the y-axis, you are actually going to count a variable. So we just write count. So plot dot title, what title you are actually using. So you are using distribution. Plot dot show. Let's see what results we are actually getting. We are waiting for the result. Oh, we have made a mistake here. Plot dot histogram. Actually, we are going to use this instead of this plot dot figure. We are going to actually give the size of the figure. So fig size equals to 6 comma 4. So as you see that we have see the result here like this. We have actually matplot using a matplot library where we have seen that how sepal length actually looks like. So this is actually the ranges of sepal length. So the sepal length having 4.9, I think, I guess 4.9, having the values of 16, almost 16. So in this way you are going to predict that actually what sort of length are going to be count here like this. So we have done this. For the sepal length, you are either just copy and paste for the uh, sepal width and petal width. Sepal width. Yes, this is the correct name. So as you see that the sepal length has been varied from a lot of values having 3 centimeter sepal width contains in the dataset have a large number of values, have a large number of flowers having sepal width of approx 3.0 centimeter. So this is actually the count of this. We have visualized our sepal width. In this manner, you are going to visualize the petal length and petal width. But I am not going to reuse this again, but you can, if you want, you will do this. Now afterwards we are going to train the model on the base. So if you are going to train the model, actually, how will you actually do training? So if you'll see this here, we are going to make the model from, we are going to use sklearn model selection. This is actually the uh, model training condition that you are going to use um, sklearn model. So we are going to use here, it is one of the model which we use most necessarily in data science, sklearn dot model selection. So in the sklearn model selection, we are going to use what, we are going to test and train the model. So we will use, we are going to import train test split. Afterwards we have on the, for the training sessions we have variables. So we are going to use two variables here, like x and y. So in the x you are going to use data frame, but in the data frame you are dropping the column. So in order to drop something, you will write the command like this: you are dropping column equals to species. I am going to explain you here what we have done so far. Y equals to df species print x dot head print y dot head parenthesis and parenthesis here. So what we have done in the x, we have stored all the variable, all the kind of columns, but except species. So if, so what remains in the column species is remaining. So in, so for the species we are going to use another variable which is y. So y is stored species, and in the x all the columns is stored but except species. I hope you understand this. Let's run this. Okay, we have, yes. Now let's run this. We will see the result here. Okay, so we have used columns. So the result is on the wait. We are going to see the result here. We have, what for the modeling we are going to use sklearn. Here we have used sklearn. So we have to see that what errors actually, okay, s is small. As you see that in the data type, this is the advantage of using printing the file. So we have seen that the what error we have made, we have used capital S. So you have to be very careful while you are using reading this kind of file. So you have to use exact the same name as printed here. So we have to use species small here, S, and here S. Now let's print this. So as you see that now the result is okay. So what we have done, we are going to train the model, and for the training model we have used sklearn scikit-learn library. It is very keen and very useful for the data science for the model training. It is one of the kind of model trainers which we use in our data science projects. Afterwards we are going to actually train the model. So we have actually two types of things, either training and either testing. So we are going to use both, so we have to initialize first here. So x train comma x test. Okay, afterwards we have y train and y test equals to. So what is the actually name of our model? Train test split. So we are going to use it here. Train test split. So in the train test split, what we are, which uh, columns or which kind of data we are using, we have, as you as you going above, we have used two kind of variables, x and y. So you are actually using x and y here, so you have to give x comma y, because the variables which we are using for training, you have to mention it here, like x comma y. And actually what size you want, so we want test size should be like test size 20%. So you will just write point 0.2. Random state should be like 42. 42. So what we have done so far, actually we have using test training model, and in the testing training model we have what variables we are going to involve. So we have involved x and y. Afterwards we are going to, you are actually predicting that what, how much size you are actually using for testing. So we are actually using 80% of our data for the training. We are actually training more than testing, because if you will give so many values and you ask for the little values, then it will, there is a high chance of good accuracy. But when you're using low kind of testing, low kind of training and high kind of testing, then there is a chance of error. So in order to modify this, we have what we have done, we have using 20% of data for testing and actually 80% of the data for training. So this is a very good model. So afterwards, print training set size. We are going to see what is the training set size for the visualization. X train dot shape. We are just going to print the data, nothing else here. Control V. Training, not this, they are we using testing here, so we will print testing x test. So this time we are using x testing. Now let's see what happened with the result. So as you see that for the training we have used 120 training set, and in the training set how much value which we are using for testing is 30. So actually if you have 150 values, then 120 is used for training and 30 is used for testing, which is actually a very great model. I hope you understand this kind of thing. This is actually the training, rough and tough. You just have to use copy it and make it according to your implementation. Either if you want to make this 30%, you will put here 0.3. If you want to make it 40%, you will either put 0.4. So it is very simple and very basic kind of thing. You just use once, and then you will copy and paste again and again in your any kind of files. So you just don't have to remember this. You will either find it on the scikit-learn library and you can implement. So there is no need of worry that how you can actually remember it. You just have to familiar with it, and you have to be make sure that how you are going to use it. I hope you understand this. So far what we have done actually, we have loaded data, we have visualized data, and we have trained the data. Now we are going to check accuracy of our model, that how our model look behave when it comes toward the accuracy. So to do this, we are actually using, so for the training purpose you have to use, um, so right now what you have done, you have done that how much part you are actually using for the training purpose and how much part you are actually using for the testing purpose. But right now you haven't used any kind of model actually. So in order to use the kind of model, what model you are actually using, so we are using best suited model, which is decision tree classifier. So in the classification kind of problems, we are actually using decision tree classifier. So now this is actually the part which we are using to implement the model. So above, before this, what we have done, we have actually done that we have make how much part we are actually making for the testing purpose and how much part we are actually using for the training purpose. But now we are going to introduce our model, which is actually decision tree classifier. So from as you are just using simple it, control C, control V, and in the SQL learn model selection, you are actually using decision tree classifier. Now you can use your model now. Model equals to decision tree, copy and paste here. You are just using another variable for it. Regardless of writing this whole, you are actually putting your this in another variable, which is model. Now model, you are actually fitting your model dot fit. In the model what you are going to use, you are actually using x train, comma y train, y train. So in the model, what you are actually fitting, you are fitting your x train and y train model. So after modeling this, you are testing. So actually what we have done, we have done x train and y train model to be fit in decision tree classifier right now. Now let's see, is there any kind of error like here, decision tree classifier cannot import name chain. Okay, so I think we have made a mistake here. Decision dot tree classifier. Should, okay, so we have to use caps lock classifier. Okay, sklearn dot tree. No, Let's implement this. So you see that now we have made a little mistake that we have done. We have improved from sklearn dot decision from sklearn dot model training, which model have been trained, but now you have to re-emphasize that what model you are actually predicting. So we are going to use decision tree. So you have to mention that tree model you are actually using. So you will write here like this: from sklearn.tree we are actually importing decision tree classifier. This is the right kind of method which are using in data science. So as far as data science concerned, you are actually making some kind of mistakes and errors, but afterwards you are going to um, remedify it again and again. It at times you are going to stuck somewhere, but you have to be very careful with your process. Afterwards training the model, what we are going to we are actually making predictions. So our training model has been completed. Now we are going to prediction process. So our y predicted, so actually our y predicted, so why we are using y predicted? Because we are actually checking our output is y test. So y test should be matched with y prediction, and y prediction is actually storing the variable which contains x testing. So actually testing of x are going to be utilized in y prediction. So this is actually our model look like. You have to understand this. Now we are going to simplify it here like this, that equals to model dot predict x test print y predict slicing fifth. So what actually we are doing, we are checking accuracy between our y predicted and y tested. So actually what does it mean? So you have to understand this, that we have one output, the output is y, and the testing output is y test. And which parameter use which we are using and comparing it with y test? Actually we are testing y test with y predicted, because these are two meta parameters which we are going to use for the comparisons and checking the accuracy. I hope you understand this. And in the y predicted, actually we are using x testing, because y is actually what y test is actually come out directly, but y predict is actually based on x test. We are actually checking that if the change in x actually bring the change in y. If yes, then how much change it actually makes. So in order to simplify this, we are actually using x testing in the y prediction, and then we are going to compare y predict with y test and check is there any kind of error. If yes, then how much error and how much we are going to remedify it. I hope you are now capable of understanding this. So actually we are going to use, okay, y predict, my mistake. Now as you see that the model which we have made, and in the y predicted, actually the first five variables which we have assigned is versicolor, setosa, virginica. So actually the result are going to be stored in y predicted, and we have seen here like this. Okay, so actually there are results in y predicted, and there are also result in y tested. Now we are going to check that the y tested and y predicted have the same result. If yes, then our model is satisfied and our model is great. But if there are changes, then how much changes is there are more than 50% changes, is there are worst cases. So actually we are going to see this here. So this is actually the result of y predicted. You can either check y tested in order to verify that the model is actually how much fluctuating with the real ones. So after that we are going to implement this. Now you are actually using checking accuracy. So now our step is to check accuracy. So we are going to use from, again we are using sklearn library, scikit-learn. It is a very powerful library which we can use most of the time in data sciences. It is one of the backbone of the libraries. Matrices, import accuracy score. So this is the syntax of using how you can find accuracy of between the two things or more than two things. Accuracy is actually the variable accuracy equals to accuracy score, which you have initialized this here. Accuracy score. Now between what are the two variables which we are going to use for the accuracy test? As we have mentioned earlier, that we are going to check the accuracy between the two y's. And what are the two y's? Actually, one y is y predicted, while the other y is y tested. So we are going to check that how much the change occur in both the variables y tested and y predicted for the classification and for the betterment or for the checking of the model. So we are going to use here again like this y test. Actually we are checking the result between y test and y predicted. Print accuracy. Now let's see what happens to the result. Okay, another, there is no need of now. As you see that our model is accurate 1.0. It means that our model is very accurate. It does not contain any kind of error, as its accuracy is 1. So it is 100% accurate. So it is very good sign for us. But ca- it can be if it contains any kind of errors, then you can check and implement a more better model. But for now it is okay and our model is very good. Now what we are doing, actually we are checking that is our model is capable of predicting the flower based on the input. So if you are going to check this, we are actually testing the model that if I know that our accuracy is 100%, but actually we are checking that can it be capable of classify that the data given data is using for Satosa, Virginica or versicolor. So can it be capable of differentiating the three species? If yes, then how? So we are going to give any raw data here like this, new data. So we are actually using the, I am going to actually I am giving the data of Satosa. I want to know that can it predict that the given data is for Satosa? If yes, then our model is actually behaving well. So 5.1 comma, it is actually sample length. Then we are using to sample width, which is around 3.5. Then petal 1.4 and again 0.2. So we have actually given our data of the four parameters: sample length, sample width, petal length, and petal width. Now we are using another variable, predicted values. Let's suppose predicted species. equals to, then what actually we are using model prediction. So we are going to use variable model predict to make us predict at what has been given to you. So actually in the bracket you are going to use the name of the data, which is new data. Afterwards you are going to print your result, print predicted species. Now see that our model is predicting or not. So as you see that actually it is going to predict, it has predicted the Satosa, which is very accurate that this data is actually for Satosa. So as you see that our model is actually behaving well, and it is going to classify between the three species. So I hope you understand the whole project. I am going to summarize it again here. So first of all, what we have done, we have to actually using actually loading the data. So as you see that we have downloaded our data from Kaggle, and whose destination is this. So we are going to we have read the file which is stored in df. Afterwards we see that visualize the every kind of flower's length, that in the data, if any flower having 3.0 length, then how much, then how many flowers are actually present of 3.0 length. If any flower has the width of 3.5, then how many flowers are actually present having length of 3.5. So in order to see this, we are actually visualize this in the form of histogram. After this we have train the model, that how much model we are actually going to train, that either you want to 20% of the model to be for testing and 80% of the model for the training, or if you want to make changes, then you are actually use it again. Then in the x, what in the model training you are actually going to use two kind of things, two kind of variables. So and one variable is x and other variable is y. In the x we have use all the necessary columns but except species, because in the y, which why we use actually y, we are going to use y to see our results. So that this is a very major importance of y. So y is actually using for the predictions, for the output. So that is why we have used only to check the result. So we have stored species in y, then we have print our results here. Then we have, as I mentioned, that we have trained the model, that our testing model is 0.2. It means that our testing model is 20% testing and 80% training. Then we have checked the size, that if 150 rows of data have been given, then how much are going to use for training and how much are going to use for testing. So as mentioned here, 120 is used for training and 30 is used for testing, which is actually zero point 0.2. Yeah, it means 20% of the result. Now for the classification purpose, we are going to, there are so many kind of tools, but we are actually using decision tree classifier, which is very accurate. Afterwards we have checked that in the prediction what kind of things are stored. So as you see that in the prediction we have stored the flowers name, this, which is actually present in the dataset. Now, afterwards, we have checked that the accuracy is good or not. If the accuracy is not good, let me explain here. If the accuracy is not good, then you are going to use any kind of other model trainings to make your accuracy good. But for here, it is one. It means that that you have used the correct model. So why this is the importance of accuracy. Now we have checked that either our model is actually predicting the right flower or not. So as I have mentioned that I have given the data of Satosa, and it has given me the result of Satosa actually. So this is the climax of this first project of data science with the wholesome moments. I hope you understand the whole project. It is very amazing project, and it contains a lot of hard work and knowledge, but it required practice. Once you have done hands-on experience on it, you are going to make so much program like this. Thank you so much.